Hi everybody, welcome to Mitch Maths. My name is Mitch, and in this video we're going to be looking at standard form. So we're going to be looking at what it is and why is it useful, and then we're going to be looking at how you add and subtract numbers that are written in standard form, and then we're going to be multiplying and dividing them as well. Okay, so what is standard form then, and why do we want to use it? So any number can be written in standard form, but it's especially useful for when numbers are either really big or really small. Okay, so I'm talking numbers into the trillions and above, or numbers that are 0.000 for 10 plus zeros and a few numbers on the end. So numbers which are really annoying to write out in their whole form. Okay, so that's where standard form really comes into play, and I'll show you some examples of why that works. So this is how we write standard form, okay, where A represents a number between 1 and 10, and then n can be any whole number, okay, so that's negative or positive. So to give you an example of this then, so example could be something like 5 times 10 to the 7, okay, so our first number here is between 1 and 10, it's 5, and this one is any positive or negative whole number. So here we've got 7. Okay, so the way it works then is if we start with our number here, so our 5, whatever number we have here to the 10 to the power of this tells us how many zeros there are before or after this number. So this one then, so because this is a positive number, that means that this is a really big number. Okay, so we've got lots of zeros after the 5. So in this case, it's 10 to the power of 7, so we know there'll be 7 zeros. So this number, written in the proper way, would be 5 and then 7 zeros afterwards. So 1, 2, 3, 4, 5, 6, 7. Okay? In other words, 50 million. Okay? So obviously, you can see pretty quickly where if this got to a really high number, say 20 or 50 even, or more than that, you'd be here writing 50 zeros out for ages. Also, you don't want to do that, so that's where standard form comes into play, and it's just a really nice, quick, neat way of writing these really big numbers. And then in a similar way, if this was 5 times 10 to the minus 7, there'd be 7 zeros the other way. Okay, so you have 7 zeros, 1, 2, 3, 4, 5, 6, 7, and then our 5 on the end. And also there'll be a decimal point in there somewhere, so it's always after the first 0. So this will be our number, 0.000005. Really small and really annoying to write out all these zeros at the start. So again, that's where standard form comes into play, and we can just write it in this really nice little quick 5 times 10 to the minus 7. Okay? Another essential skill you need with this sort of thing is to be able to go the other way. So if you had a really big or small number, show that written in standard form. Okay? So for example, if we had 7, let's have 6, 1, 4, and then some zeros afterwards. Okay? So we'd have this, this, and this. So this number would be 76,140,000,000. Okay, let's have that written in standard form. So before I was saying this tells you how many zeros there are after the 5. Okay, and that is correct. So in this case, we've got 1, 2, 3, 4, 5, 6, 7 zeros here. So you could be tempted to put times 10 to the 7. But in this case, that'd be wrong, because in fact, what we actually need is our number that represents our A to be between 1 to 10, okay? Somewhere in that range. So what we do is, we want to put our decimal point to here, after the 7. So our decimal point is currently here, at the end. So our number here, our 10 to the power of this number will tell us how many places we need our decimal point to move so it's in the right spot. Okay, So we need this to be between 1 and 10. So it'd be 7.614. Okay, so we need the decimal point to move 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we need to move 10 places. Okay, so to have this in standard form then, we'd put the decimal point here. So this number is between 1 and 10. So it'd be 7.614 times 10, and we need it to move 10 places, so it's times 10 to the power of 10. Okay, and that's how you represent this long number here in standard form. And it's very, very similar if we want to convert a really small number into standard form. So if I chose 0.000000000, have another 0, and then say 891. Again, we need our number at the start to be between 1 and 10. So we want to move our decimal point so it's after the 8. Okay, so it's always after the first number that isn't 0. Okay, so we'll move it to here. So this will become 8.91. So that becomes our first number, 8.91 times 10, and then to the power of how many places we want to move our decimal point. So in this case, it will then be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 again. But this time, because this is a really, really small number, it will be minus 10. Okay? Because the minus means we're moving a decimal point one way, a positive means we're moving it the other way. Okay? Okay, so if that last bit didn't make sense then hopefully we'll break this down right now then. I'll show you what is actually going on here. Okay, so hopefully we all know that if we multiply a number by 10, we'll just add a 0 to it. So 5 times 10 is 50, or 50 times 10 is 100. 500, sorry. Okay, so each time we're adding a 0 onto the end when we're adding 10. And equally, if we were dividing this by 10, we would just take a 0 off. So that would become 50, and divide it by 10 again would become 5. And what we're actually doing here is we're just moving the decimal point. So we're moving it from here, times it by 10, we're moving it one place to the right, okay, and filling in the 0. And if we're doing it the other way, where we're dividing, the decimal point would be here, we're just moving it the other way to the left. So we're bringing it back into here, so it'd be 50.0, or just 50. Okay, and you can see that especially clearly when we use it with a decimal point. So if we had 7.86, times that by 10, move the decimal point one place into here, so that become 78.6. Okay, or if we just times it by 10 again, we want to move this another place, so it would be then 786. Okay, and as we divide it by 10, we move the decimal point back some spaces. Okay, and that's exactly what we're doing with standard form, except rather than timesing it by 10 and by 10 individually, we're timesing it by a multiple of 10. Okay, so if we want to times something by 10 to the power of 3, for example, okay, this is the exact same as writing, so 10 to the power of 3 is 10 times 10 times 10, which is 1,000. So it's the exact same as timesing something by 1,000. And if we do that, what we're doing, we're just adding 3 zeros on the end, or in a case like this, just moving the decimal point 3 spaces. Okay? And that is exactly what we're doing with standard form. Whereas the reason why it might not look like that is because this number is usually much bigger. So this is by 10, we're actually timesing it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're timesing it by this number here. And we treat this exactly the same as we would with any other multiple of 10. Just count the zeros and then move the decimal point by that number of zeros. Okay? I hope that made sense. And of course, if we have a negative 3 here, what we'd actually have then is, so 10 to the power of minus 3. So you can see this in another video of mine of we were looking at powers, but this would actually be 1 over 1000, which is the same as 0.001. Okay, and in this case, because it's now the other way, when we multiply this by a number, we'll be moving the decimal point back 3 spaces, because we've got 3 zeros on this side of the 1. Okay, I hope that made sense. I hope that made it a little bit clearer. Once you've got to grips with what standard form is, we can then move on to how we add and multiply them. Okay, so now we're going to be looking at then, how do we multiply and divide numbers in standard form? Okay, so we've got an example here then. So we've got 2.5 times 10 to the 4 times 7.43 times 10 to the 6. Okay, so multiplying two numbers in standard form. So the way we do this then is when we multiply them, we want to take the two numbers out the front and we multiply those. So say 2.5 times 7.43. Okay, so we break this down into its individual parts. So we take the first two parts out and multiply them. And then what we do is we then multiply our 10 to the 4 times our 10 to the 6. Okay, so if we do our first bit first, then I'll grab my calculator. So we've got our 2.5, turn that on, 2.5 times 7.43. Okay, so that gives us 18.575. So that's the first bit out here. So now we've got this bit here where we want our times 10 to the 4 times our times 10 to the 6. Okay, so the rule we have then is when we multiply numbers like this, which are the same number, just the different powers, we multiply them, we keep this number the same, and then we add the powers. Okay, so this just becomes 10 to the power of 10, because 4 plus 6 is 10. Okay, and then we want to keep this in standard form, so we want to keep this as times 10 to the 10. However, this is not currently in standard form, and that is because this number at the front must be between 1 and 10 to be in standard form. Okay, so we must convert this. So the way we do that then is we just look at this number and we look at what we need to multiply 10 to the power of something by to turn this into standard form. So we want to put the decimal point back a space here, so it becomes 1.8575. Okay, and we need to now think of how do we multiply this then to get back up to here. So what we'll do is we'll multiply it by 10. Okay, so we need this number multiplied by 10 gives us this, and this is still times 10 to 10. And then just to tidy this up then, 10 on its own is the same as having 10 to the power of 1. So now we can follow the exact same rule that we did up here then, where we add the two powers. So here we'll just add them together. 10 plus 1 will be 11. So this in standard form would be 1.8575 times 10 to the 11. Okay, and that's the answer to this one at the top. We just take the two numbers out the front, multiply those, and then add the powers, and then just to do a little bit of tidying up at the end to convert it back into standard form. So now to give you an example of dividing then, we'll use the exact same example with the same numbers, but this time dividing. Okay, but we follow the exact same rules as we did for multiplying. So we want to take our two numbers out the front, so our 2.5, and we want to divide this by 7.43. So we've got 2.5 divided by 7.43, and then we want to then keep this by times 10 to the 4, and we want to divide that by our 10 to the 6. Okay, so we'll do our first bit out the front to start with then. So we want 2.5 divided by 7.43. Okay, and that gives us 0. I'll do this over here actually. 0.33. Let's do it to 3 decimal places here. 6. Okay, and this time when we have over here our powers to 10 to the powers, now we are dividing them, whereas before we added them together because we're multiplying. Now that we're dividing, we want to subtract them. Okay, so this now becomes times 10. 4 minus 6 is minus 2. Okay, so that gives us this 0.336 times 10 to the minus 2. But again, just like the previous example, this currently is not in standard form because this number at the front is not between 1 and 10. So what we want to do then is we want to move the decimal point this way 1. So this will become 3.36. And what we've done here, to get this back to this number, we want to divide this by 10. Okay, so we want to divide it by 10, which is the exact same as writing by 10 to the minus 1. Okay, and then this is still times 10 to the minus 2. And so then to tidy this up then, this would be 3.36. And now that we're multiplying these together again, we now add them. So minus 1 plus minus 2 is minus 3. So that would be times 10 to the minus 3. Okay, and that is the answer we get then to this division up here. And we'll just check that on the calculator. So we'll say 2.5 times 10 to the 4. Okay, divided by 7.43 times 10 to the 6, and that gives us 3.36 times 10 to the minus 3, which is exactly what we got here. Okay, so now we're going to look at how we add and subtract numbers in standard form. So when we're doing this, it's kind of similar to how we do fractions. So remember, in fractions we want to only add and subtract them when they have a common denominator. Okay, in standard form we only want to add and subtract them once we've got a standard part at the end. So i.e. this 10 is to the same power in both parts. Okay, and then that makes it really easy to add. So what we want to do then is we want to convert one of these so it's the same power as the other. Okay, it doesn't matter which one you want to convert. You can do whichever one is easiest for you. In my example right here, I think I am going to choose this one to convert into a 10 to the power of 4. And the reason for that is because this number will get bigger, so it'll be 470 or maybe one above, as opposed to this one getting smaller, being 0.00 whatever something. Okay, so I'm going to choose this one to convert into a 10 to the power of 4. So the way we do that then is we take our 4.7 and we want to times this by something that will then convert this into a power of 4. So if we think about this part here, then we want to convert it to the power of 4, so it'll be 10 to the power of 4 multiplied by a number to the power of 10, or 10 to the power of a number. So to get this into a 6, we need to add 2 to it, so this one would be 10 to the power of 2, okay? In other words, this would now be just 100. 10 to the power of 2 is 10 squared, 10 times 10 is 100. So what we can then do is we can then multiply this number at the front by this 100 we've just got here. So 4.7 times 100, so we move the decimal point twice, so this will become 470 times 10 to the 4, okay? And now we have just converted this number into this number here, where the 10 is to the power of 4, and we want to add our 2.1 times 10 to the power of 4. So the way we can do that then is we essentially just add these two numbers we've got at the front here. So we take 470 and we add 2.1. So this will basically just become 472.1 times 10 to the 4. Okay, so that's those two numbers added. Now we want to convert this back into a number in standard form. And remember, this needs to be between 1 and 10. So we need to move our decimal point back 2 spaces to here. So it becomes 4.721. And we want to times this by 100 to get to this point. So that would be times 10 to the 2. Additionally, keep our point at the end, our 10 to the power of 4. So in standard form, this number will become 4.721 times 10, 2 plus 4 is 6, so it's times 10 to the 6. Okay, and that is the number when we add together these two. And as you can see, this number is very similar or not too far away from this number here. And that's because we need to now think about what we're adding. Okay, so because this one is times 10 to the 6, this one's times 10 to the 4, because 6 is bigger than 4, this number is actually quite a bit bigger than this number. So if we've got a big number and we just add a little number onto it, we're still quite close to this big number. That's exactly what we found here. So this is quite deceiving, whereas a small change in this number here actually makes quite a big difference to the value of this number. But because it's written in standard form, this might not be obvious. But think about, for every 1 you add here, you're actually timesing this number by 10. So if you're adding, if this increases by 2, times it by 100, by 3, by 1,000, by 4, by 10,000, by 6, by 1,000,000. So as you can see, if you increase this number here, this value increases drastically. Okay, and this method works exactly the same way for subtracting as well. So what you want to do is you want to convert one of them so it's got the same 10 to the power as the other one. And then rather than just adding the two numbers out the front together, you just want to subtract them and then convert it back to a number in standard form, just like I've done in this example. Okay, I hope you guys found this video useful. I hope you learned about standard form, about what it is, what it's used for, and why it's useful. If you want to see more videos from Mitch Maths, then head over to my YouTube channel and head over to my website as well. And thank you very much for watching, and I'll see you in the next video. Thank you very much.